Good morning and welcome to today's class. Today's class is a continuation of our previous class on indices. At the previous class, we had a revision on standard form, where I showed you how to express numbers in standard form from ordinary form and from ordinary forms back to standard form. In today's class, we shall then look at indices, having learned what standard forms are and how to express numbers in standard forms. Today we shall be looking at indices. Indices can be said to be the plural form of index, while a number is said to be in index form when it multiplies itself a lot of times. For example, we have t cube. T cube is said to be in index form, and t cube simply means t multiplying itself 3 times, as well as k raised to power 5 as being expressed as k times k times k times k times k 5 times. So when a number is expressed in this form, it is said to be in index form. In indices, we have 2 terms I would like us to consider. We have the base term as well as the power. 3 and 5 represents the power, which we also refer to as in mathematics as, it can either be called index, power, or exponent. They all mean one and same thing. It means the number of times the base is being multiplied by itself. Let's now look at the laws of indices, having understood what we meant by indices. From our junior mathematics or junior secondary, we learned the following basic laws of indices. The first, in no particular order, we have b raised to power x, b multiplied by b raised to power y. Law of indices tells us that it is equal to b raised to the power of x plus y, and we refer to this as the addition laws. Now, for these laws to hold, it therefore means that the bases must be equal. That is, b raised to the power x times b raised to the power y will give you b raised to the power of x plus y. Also, 2, which is the second law, b raised to the power of x divided by b raised to the power of y is said to be equal to b raised to the power of x minus y, and we refer to this as the subtraction laws. Meaning, if the bases are equal and you're asked to divide one index from the other, you are simply to subtract the powers or to the base. 3 says b raised to the power of 0 is equal to 1, where b is not equal to 0, and we refer to this as zero index law. That is, any number raised to the power of 0 is said to be equal to 1. Let's take some examples that we should simplify each of the following. 1, b raised to the power of 5 times b raised to the power of 2. With our understanding on the basic laws of indices, you know that this can be said to be the addition law. And in the addition law, it says once the bases are equal, you add the powers. So this is going to be equal to b raised to the power of 5 plus 2, which is equal to b raised to the power of 7. And I'm going to prove this to you using the expansion method. In the expansion method, we can simply write this as b raised to the power of 5 times b raised to the power of 7. And b raised to the power of 5 can be said to be b times b times b times b times b in 5 places. B multiplied by b squared, meaning b times b. And invariably, your answer becomes b raised to the power of 1, 2, 3, 4, 5, 6, 7, which is the same thing as using the addition law. Same thing goes to the division law. When we get to that, we'll be able to solve it. Now, example 2 gives us another example that has to do with addition law. That says 5b squared to be multiplied by 2b cubed. How are we going to apply the laws of indices in solving this? Now, when you are faced with such a problem, where you are asked to multiply this given a constant, all you need to do is to first of all multiply the constant using the ordinary laws of mathematics. That is to say, I'm going to pick out the constants, which are 5 and 2. So I'm going to multiply 5 by 2, simply because these are not in they don't obey the laws of indices. Although this is 5 raised to the power of 1 and 2 raised to the power of 1, but simply because their bases are not equal, laws of indices cannot hold. So this is 5 times 2 into b raised to the power of 2 times b raised to the power of 3. You can then apply the law of indices with b's. Okay, so this is going to be 5 times 2 is 10, and b raised to the power of 2 times b raised to the power of 3, the law of indices says is equal to b raised to the power of 2 plus 3, and this will be equal to 10b raised to the power of 5. I hope you are following. In the next example, we shall be looking at the subtraction law, where we have y raised to the power of 4 divided by y squared. Applying law of subtraction, which is one of the laws of indices, this becomes y raised to the power of 4 minus 2. That once it is division and the bases are equal, you subtract the powers. So this is equal to y squared. For 4 minus 2 is said to be 2. So this is equal to y raised to the power of 2. 4. 18x cubed divided by 3x squared. You are going to apply the same method I used in solving 2, whereby we first of all deal with the constant and thereafter apply that of laws of indices. So this is going to be 18 divided by 3 into x cubed divided by x squared. For 18 divided by 3 is said to be 6, while x raised to the power of 3 divided by x raised to the power of 2 is said to be x raised to the power of 3 minus 2. And this ends up giving us 6x raised to the power of 1, which is same thing as 6x. 5. R raised to the power of 7 divided by b raised to the power of 0. Now, you cannot apply the direct laws of subtraction because their bases are not the same. But that doesn't mean this cannot be solved. For we already know that from the third law of logarithm of indices, I beg your pardon, which we said b raised to the power of anything raised to the power of 0, that's the 0 law, is equal to 1. We can therefore apply it in solving this by saying r raised to the power of 7 divided by 1, because b raised to the power of 0 is 1, and anything raised to the power of 0 excluding 0 is said to be 1. So r raised to the power of 7 divided by 1 is said to be r raised to power 7. Number 6. M raised to the power of 1 over 3 times m raised to the power of 3 is equal to, since the bases are equal, you add the powers because of the multiplication. So this becomes m raised to the power of minus 3 plus 3. And m raised to the power of minus 3 plus 3 is said to be m raised to the power of, for minus 3 plus 3 is 0, and this becomes 0. So therefore, m raised to the power of 0 is 1, going by the 0 index law. That brings us to the end of today's class. In today's class, we have been able to look at the basic laws of indices and how to apply them in solving simple problems. That's to simplify indices. In the next class, we shall be looking at other laws of indices, which includes the product laws and power laws. Do have a nice day, and please, while you watch, kindly like our videos and use our comment section to express your feelings on our lessons, as well as you share to your friends so that they can also benefit from this project. Good day and have a nice day.